Hello, my name is Juan Carlos Bejarano Moreno, and today I will present my final stage delivery of the key activity, Hot Wheels, Asphalt, and Heat. First of all, my general idea. The idea of a plastic tier as a substitute for a rubber tier, as the rubber tier can contaminate the environment. For example, rivers, and when you burn a rubber tire, it creates like a lot of smoke in the area. For this, you can make a plastic tier that is made of reused or recycled plastic, for example, plastic from bottles or even toys, for example. And in this case, the only plastic tire that I have actually is a plastic tire of a Hot Wheel. So I want to see the test this tire on a surface like asphalt, that is the most common surface for a tire, and have a possible application on all vehicles like cars and trucks, for example. So my theoretical framework was that the nature of the wheel of a toy that is made of plastic can be affected by the heat. You can see that the plastic can get weird. It can be like it can melt. It can melt the plastic with enough heat and sun. So as friction works, it can even increase this difference in velocity and in properties of the wheel, as the temperature can affect the friction. For example, a colder surface can have less friction, so it can be even different. It can even increase the velocity, for example. And being able to determine if the heat can affect the friction on speed of a plastic wheel. So my methodology of the experiment is the test the time of displacement in two surfaces, in this case concrete and asphalt, and take 3 samples of time per test, 3 at 7 a.m. and 1 p.m. I choose the 1 p.m. hour that is after the midday hour, in the most heat moment of the day, so that the asphalt can get enough heat. And the 7 a.m. because it's the cold of the night, it's after the cold of the night, and it starts to get a little hot in the environment. So I want to choose this hour, mostly for the cold. The car was launched by a Hot Wheel launcher. I think that force, it was from 0.18 newtons. I added later in the presentation. And the car moved a distance of 60 centimeters. The time was recorded as well as the temperature of the moment of the day. The materials were a flexometer to record the distance, the chronometer, a phone to record Hot Wheels on launcher. The studied variables were my dependent variables, the time of displacement and the temperature of the surface. The control variables are the hour of the day, the objects of test, the Hot Wheels, for example, and the surface of test. The independent variables are the force of the wind, the temperature of the day, the acceleration of the car, and the velocity of the object, and of course, the force of the launcher. The results that I get were pretty variable. As you can see in the asphalt, we can see a change in time. It changed from 0.3 seconds of displacement on 7 a.m. in asphalt to 0.4, almost 0.5 seconds after midday. In concrete, you can see a decrease actually on time. You can see that the time got from 0.5 in average to 0.3, 0.36, almost 0.35, but I move a little bit the number. The force of the launcher was from 0.18 newtons and the mass of the car was from 40 grams. And the velocity, acceleration, and temperature. You can see the formulas that I used, and as I mentioned before, we can see a decrease in velocity from the asphalt, in the case of the asphalt, from 1.94 meters per second to 1.3 meters per second, and an increase in velocity in the case of the concrete, 1.3 meters per second to 1.7 meters per second. And a similar case in the asphalt, you get a decrease in acceleration in asphalt, but an increase in concrete. The temperature of the environment at the moment of the test were 11 Celsius degrees at 7 a.m. and 22 Celsius degrees at 1 p.m. My analysis of the data: an increase of the acceleration on concrete from 2.95 to 4.64 meters per second and meters squared per second. Decrease of acceleration in asphalt, as well as a decrease of velocity in asphalt, an increase of velocity in the concrete, and we can perceive a relation between the temperature and the velocity. An increase in velocity was like less velocity in the case of the asphalt, but in the concrete it was like increase of velocity, and with the change of temperature as well. For my congruency of the results, we can see that because of the asphalt, of the nature of the asphalt, the materials that it's made like little stones. These little stones, after the time of and use of the asphalt, they get away from the material and they become like these little stones. This is a normal effect of the asphalt. So these at the end make an irregular surface that it can affect the test because of the small size of the object, in this case the Hot Wheels. And not a similar mass of a car. The Hot Wheels have a smaller mass and not a real tire. Of course, it's designed for a plastic highway, for a toy. It's a toy at the end, and it's not designed for common use in a highway or in a normal street made of asphalt or concrete. And not a complete test of application, more like a test of a temperature over the material of the object, and a change in speed. That's true, a change in speed and acceleration can be seen in both surfaces. My conclusion of the experiment is that an alteration of friction and velocity, as well as the acceleration, we can see that a possible application on cars, and not a reliable effects on the tire because, again, it's a toy. It's not designed to be used in a highway or in a street made of asphalt because of the irregularities of the surface and etc. It's made for a normal and plain highway made of plastic. How to improve this experiment? Get a prototype of tire, an actual tire for a car. I don't know, for a Corolla, for example, or a Golf, and get this tire for this car. Get a better sample of the surface, for example, more cleaner, and that was everything. Thank you so much. Here is my app. Thanks.